So welcome to the Science for Community lecture series on the Chesapeake Biological Lab. We welcome the 30 or 40 people in the room with us at CBL, and we welcome those who are joining via Zoom. This is the second of 5 presentations that we'll do this autumn. There's 3 coming up in the next 3 Tuesdays, focusing on diamondback terrapins. Next week, one of our researchers, Dr. Chris Rao, will talk about how climate change may be affecting the sex ratio in diamondback terrapins and putting the sustainability of restoration efforts at risk. The following week, so week 4 of the series, Jamie Tester is talking about Dolphin Watch, one of our most impactful citizen science programs that welcomes sort of 10,000 people to log their sightings of dolphins on the Chesapeake Bay. That has revealed some fundamental insights in what dolphins are doing when they're in the bay, where they are in the bay, when they are in the bay, and also provide us with just some remarkable photos of dolphins that are really sort of National Geographic standards photos, which are a real pleasure to see. And then the final of the 5, Dr. Walter Boynton, who's an emeritus professor here at CBL and has been studying the Chesapeake Bay for most of his career, will be talking about his sort of thoughts and observations on how the bay has changed and what might need to be done in the future to continue it on a restoration trajectory. All of these presentations are recorded. You're welcome to go back and look at any of the ones we've done over the last decade. There are now some 100 or so presentations on the web of speakers talking about their research, talking about what they do and why it is important. And this session will also be recorded. Before I introduce tonight's speaker, I need to thank the kind people at Southern Maryland Toyota and Team Hyundai who are providing the snacks in the rooms. I had a dental appointment tomorrow morning. I wish I'd remembered that before I had the caramel corn. So I will get talking to my hygienist tomorrow morning. But we thank Toyota and Hyundai dealers for their support of the session. So tonight is my colleague, Dr. Dave Secor. I was thinking earlier on this afternoon, as I thought about what to say, I first met Dave in 1988 in Bergen in Norway. We were both bright-eyed graduate students going to probably our first international science conference. And it is remarkable how close our careers have been since then. We both joined CBL at about the same time. Dave predates me by 4 years. He joined as a postdoc in 1990 and then joined with me the faculty in 1994. Since then, Dave has done some extraordinary work exploring the life histories of fish, what fish do in the environment, letting the fish, or in many cases, the body parts of fish, tell their story, where they are, how they're growing, where they go back to spawn. Throughout that time period, as many of the researchers at CBL do, he has engaged in the community, both locally, nationally, and internationally. He serves as an advisor to regional fishery management councils. He works with the International Council for the Exploration of the Sea, which is the major international organization that manages fisheries and ocean issues in the North Atlantic basin, and is a highly regarded, internationally respected scientist. Throughout that period, Dave has had an interest in odd fishes. And this is the story of one of those odd fishes. It's the story of Sturgeon, the possible extirpation of Sturgeon, I'm sure will come up, and rediscovery of Sturgeon. And so it is a real pleasure for me to introduce my friend and colleague, Dr. Dave Secor. Dave?
Thank you very much for the kind introduction here. All right, so there's a lot of unpacking to do about sturgeon. Can everybody hear me all right? So I'm going to let a professional do it for me. So reckless, that's not a word I should use as a scientist, is it? I took that under advisement. I really struggled with reckless, but wouldn't be prudent just didn't fit the bill on this one. This was a real line in the sand. This was something that really could jeopardize this sturgeon population. And this put me squarely in the role of being an advocate. And that's something I really haven't done in my 30+ career. Tom knows my proclivities. So in any case, I was going to have to advance an agenda, cause in the public arena. And I want to spend some time unpacking that a little bit for you today as Dave becomes an advocate. And our fisheries group here at CDL, we do provide a lot of advisory work. But when we do so, we had to do it as a group, under rules of consensus and under rules where we don't offer advice unless it's asked for. And when it's asked for, it's pretty kind of strict guidelines in terms of how we respond. So we follow the gallant mode. If you go out on your own and being an advocate, you risk becoming a goofus. You risk being conceived as reckless yourself. You're putting yourself out there and you don't want to be a loose cannon. You don't want to undo this kind of trust that the public has in your scientific advice. So in terms of aquacon and its impact on sturgeon and trying to stop it, there could be all kinds of reasons for doing this. And these are reasons that I heard from other stakeholders, and they're perfectly legitimate from their point of view. But as a scientist, I have to stay in my own lane. And that means it's got to be scientifically defensible. And so I came up with what I thought I could advocate that was defensible, but also allowed me to have a little bit of a value system in this. Should is a word that scientists should never use, except when it comes to this value system. And I think some people don't fully appreciate that fisheries and environmental scientists do have a value system, and that is in sustainability. That is a value that we hold up. And so when we talk about sustainability, we can use that should word. So my advocated position was that sturgeon have no choice. Aquacon does. And we'll unpack that. But there were three tenets with that. One is that the Marshyhope Creek is Maryland's only sturgeon river, and sturgeon are compelled to use it. So they have no choice. The other one was scientifically defensible, but took some more research on my part. So aquacon sighting presents too high a risk to this population. So that too. And then we get into the value part of this. Aquacon is a part of an emergent technology called recirculating aquaculture systems. And sustainability is really baked into that technology. How that technology operates is built on sustainability. It's there in the plant, it's there in the operation, it's not there in the cycle. So that's where this should come. We should also sustainably cite those kinds of big companies. All right, let's go through the first tenet. So as Tom said, throughout much of my career, I didn't give sturgeon much credit. Early in my career, I was really interested in them. I had a panel of experts. We looked at all the sampling in the Chesapeake. We saw no evidence of sturgeons spawning. We thought they were like striped bass. They were spawning in the spring, in a big part of our estuaries, and we saw no evidence for that. Then we started putting out more what are called telemetry receivers to listen to things like striped bass in our tributaries. Meanwhile, colleagues in the coastal waters, places off Delaware, New York, and shelf waters, they were tagging sturgeon. And then suddenly we started hearing sturgeon in our tributaries. At times and places we never expected them to be. And to top it off, that a recreational angler, bass fisherman on the Marshyhope, had a big adult male land squarely in this John boat. So then we couldn't ignore the fact that there was still sturgeon in our midst. And my colleague Chuck Stentz at Maryland DNR went on a mission to try to find them. And he had to teach himself and his group how to kill them for sturgeon. Techniques long lost to fisheries and fishery scientists. And after several years considered that, but he did find adult Atlantic sturgeon and proceeded to tag them with electronic tags so we could track their behaviors. And there you see him tagging a very large female from the Marshyhope Creek. I'd like to introduce my student who's giving his thesis defense this Friday. And he's holding a fish called Igor that DNR likes to name all the different fish they tag. And Igor was tagged in 2014, and he's come back to Marshyhope Creek every single year, year after year. He goes on elsewhere for winter. Many of the fish go down off South Carolina, we know, but he comes back every year. Females come back every 2 to 3 years. And then the fellow who's helping Nicholas hold this fish is Matt Baldwin, also with DNR. And Matt and others have put receivers now at the highest tidal sections of the Marshyhope Creek, 2 miles above Federalsburg. And you can see what it looks like up there. You can barely maneuver a kayak. And we have these 6-7 foot long sturgeon maneuvering up there. It's just truly remarkable in waters that can be less than waist deep. So remarkable behavior. It certainly indicates that they are compelled to use the Marshyhope Creek. Here is a picture of the Nanticoke River. It communicates with the Chesapeake. We have branches of the Nanticoke, the upper Nanticoke, which heads up to Seaford. And then the Marshyhope Creek is this tributary here, and it goes up to Federalsburg and beyond. What I'm going to show you here is an animation. We have telemetry receivers that are listening for fish about every mile where they spawn. And in this depiction, where we hear sturgeon, you can see the little black ball light up. And so in July, they're still staging in the lower part of the Nanticoke around Vienna. As we get into August and September, you're going to see them move very rapidly, because it's a daily calendar, up into the Marshyhope and into the upper Nanticoke. These large sturgeon are roving widely between those 2 spawning tributaries of the Nanticoke. They persist there throughout September, a lot of activity, a lot of roving behavior. And then late September through October, they begin to exit the system. That's called the spawning run. You can see why it's called a spawning run. They're running up the river and then they run back out. And that's a clear kind of spawning behavior we expect for an adult population using the system. So they are obliged to come back. Now we can follow their behaviors with electronic tags. We can also take pictures of them. So we can't take pictures with cameras because it's too dark and turbid. So we use sonar imaging to take pictures of these sturgeon. They're big, large fish, and that helps us. And so with leadership with Dr. John Madsen at the University of Delaware, and side scan sonar, this is typically a technique used to map bottom bathymetry in rivers in Chesapeake Bay. But you can use it to actually image these large sturgeon. And that's shown in the right panel. Oops. I guess that will use that. So that's the reflectives from the sonar, is that white line. But see what else it does? It creates a shadow. So the shadow is on the bottom, and that's a sturgeon outline. You can see the low heterocercal tail that's indicative of the sturgeon, the snout. We also get a length from this. We know this is a very large fish. We don't see fish that are over 1.4 meters that aren't sturgeon in the system. And so in 3 hours' time, John can take a small boat with something called a towfish that projects down the sonar beam, and he can go up and then back down the Marshyhope Creek, and he can get 2 counts of everything in that river. So we have count data, we have electronic tagging data, tells us behavior of these fish, and we can combine them then. So actually we get an abundance estimate, which is pretty cool. So the way this works, and you can certainly get the right way it works. You attend the Nicholas's thesis defense this Friday. I'm going to give you kind of the shortcut. So if I'm trying to count everybody in this room, which I guess I could, but let's make it more difficult. Let's let you go hide anywhere in this building. Okay? And I'm going to track down 10 of them. And I'm going to give you one of these access cards. These access cards are really cool. And we have an associate director that can track my movement everywhere by these access cards. That let me go into different labs and let me go into different buildings. She's going to get me permission to do that. So if you're carrying around one of these cards and you're going around the building trying to hide, I know where you're going. I know where the move is. All right. And then what I'm going to do is every once in a while, I'm going to take a picture of everybody in this room. Some of you be in this room just by the nature of things. And knowing the number of people in this room and your movement behaviors, I get at your abundance. So that's what the trick that Nicholas does in this integrated model. And if you're interested in learning more about that, you're certainly welcome to attend a Zoom seminar this Friday and contact Sarah. All right, so we can actually get an abundance estimate for this population. So that again speaks to this idea that sturgeon are compelled to use the Marshyhope Creek. Let's go to the next tenet. That this is risky, that this presents too high a risk for this population. This is material from Aquacon. We can go through kind of the promise of sustainability here. And this is that recirculating aquaculture systems are premised on sustainability. They have very high feed conversion. So they get a lot of growth for a given amount of feed. That's good. Means you aren't wasting feed, you're not putting feed in your waste stream. This is non-animal protein. A lot of the voices I heard against this factory where, oh, you're just feeding menhaden salmon. No, they don't do that. It's non-animal protein. So that's a very nice sustainable component. They have complex systems of waste containment and treatment, and they even convert some of the waste to useful energy through methane combustion. The bugaboo is containment. That's the promise, is we're going to move the system to land where we can control everything. But in this instance, they haven't fully contained it. We'll talk about that in a minute. But also the second containment issue, if you build something large and complex, it's not going to be contained. It's just not possible, especially with new technologies. I'll touch on that. All right, so as the able reporter Scott Broom talked about, we have to purge these salmon. We grow them in this big plant. We're feeding them artificial food, and they accumulate an off flavor, product called geosmin. And I guess it makes fish taste muddy or something. So much like we would purge an oyster before we eat it, Aquacon has to purge these salmon. And the way they're going to do it is they're going to put them in outdoor tanks, and they're going to flood them with groundwater from deep aquifers. And that's going to get rid of that off flavor. It's going to be a big flow to do this. And the only way they can do it is to actually do a flow through right to the Marshyhope Creek. So go from water, from the aquifer, through the purge operation, right back to the marshy. And so they need a discharge permit. They need to get an MD permission to do that. And that's what this brought this whole issue to a head. So you, on this figure, you can see this is the plant, the big 25 acres of impervious surface that reporter Broom talked about. Here's the pipe that takes the purge water to Federalsburg, and this is Highway Route 313, also the Federalsburg Highway, or bypass it's called. And that's where they're going to discharge that purge water. It's going to contribute a lot to the freshwater inflow. It's going to be 15 to 20% of the total flow in Marshyhope. So just that will tell you, it could affect the water quality, it could affect the temperature. We're bringing up cool groundwater. We're putting it sometimes a year into warmer water, sometimes in colder water. So that's a problem. And we'll talk about other problems as well. The other waste stream that isn't mentioned is there's a waste stream to the sewage treatment plant. Here's a small municipal treatment plant that carries all the human waste from the factory, and there'll be a good workforce there. Also, it carries all the seafood processing. And you're getting about 60% weight of fillets from each fish. What happens to the other 40%? Some might be recycled, but there is going to be a pretty big waste stream going into that sewage treatment plant from seawater, from seafood processing. All right, so that's just a lot I took you through. And now I'm going to take you through some more. But when we talk about big things being too big to fail, I'm going to turn that around and say, if you promise 35 million pounds, and there's lots of equivalencies, it's more than our blue crab harvest in Chesapeake Bay. It's more than the entire coastal harvest of striped bass. I can keep going on, and I'll have a great equivalency for you in the next slide. But it's too big not to fail. It's too big and complex, especially as this is the first time at bat for this industry to operate at that size. I've had enough experience with intensive rearing systems to know that it's really hard to keep animals alive, especially when you're rearing them intensively. It's a tricky balance of water quality, water delivery, managing waste streams so you don't get pollution, managing against disease issues, prophylactic treatments, how you deal with the root management. In this case, how you deal with rearing different stages. They're rearing them eggs, embryos, larvae, juveniles, adults, the whole life cycle contained in the building. So there's two tactics here that the industry has taken. This technology has been really well developed here in Maryland and elsewhere at marine labs and marine stations. And that's kind of thousands of pounds per year technology. We can try to build on that incrementally. And that's what some of the companies are doing. They're trying to move up to a million pound for these land-based salmon farms or factories. The other tactic is let's go for the whole kahuna right away. Let's try to capture that big market of farm salmon. And that's a huge market. So this is aquacon strategy. 35 million pounds would be a huge chunk of our demand for cultured salmon. And this is already shown to be a bad strategy by another company, a Danish company called Atlantic Sapphire, that has a plant they're developing in Florida where they set out a goal of 100 million. That would be almost the entire US market for farmed salmon. That industry has suffered two massive die-offs, hundreds of thousands of fish, and a catastrophic fire. It's just a very complex activity. And I think about the lunar space program and how we moved incrementally from the Mercury to Saturn V. We wouldn't have done that in one fell swoop. When you look at those different rockets, that's only a 100-fold difference in thrust. But look at the difference in size and complexity between those different lunar phases of exploration. It's tremendous. You don't scale proportionally as you get bigger. You're going to come up against increasing complexity issues, and that's certainly what's happened in the experience of Atlantic Sapphire. There are many risk dimensions showing here. And so it's not just environmental impacts, it's also things like animal and human welfare that come into play when you have this kind of catastrophic problem with accidents. All right, so that's a lot to talk about, and to try to encapsulate this, I picked one issue that relates to scale. And so I can science the problem. I'm going to talk about fish poop now. Fast-growing salmon poop a lot. They really do. And to figure this out, I first had to go to that 35 million per year calculation. And from that, literature values, I could get to how much salmon they would have to have in the factory on any single day. It would be 500,000 pounds. That's a good amount of fish. Then I had literature values for the feed to salmon weight conversion ratio, how much feed converts to solid waste. I had that in the literature. And from those calculations, I came up with 0.16 million pounds solid waste per day. And that's about 4 truckloads of sludge. All right. So that's kind of interesting. Now let's make another equivalency. That's looking at how much we produce. So I found some real interesting literature on that. In the US, we produce more than other countries. So it's kind of interesting. But in any case, it amounts to 4 times the citizenry in the mountains. So you think about the municipal sewage treatment plants that are necessary for that population. Then you look at the single sewage plant for Federalsburg that services a population of 3,000. You can see that if there are accidents, if the contingency of having to use the sewage treatment plant to handle all that fish sewage is necessary, we're in a heap of problems. It will create a large dead zone. the river just can't handle that kind of sewage. It's a small estuary, very small estuary, and it becomes dead for the large parts of it. All right, the last tenet was this plan is built on sustainability. And I wanted to review that because there's some really important elements of this that we should think that could be a positive thing for the region and for Maryland. First off, that Americans are the #1 consumers of farm salmon. So let me take a survey. How many of you guys enjoy eating farm salmon? It's what you buy in the grocery store. It's the pink, it's soft. Yeah, it's just, or you go to the restaurant. Everybody seems to enjoy it. So Americans enjoy it more than other folks in other countries. That supply is mostly international that comes in. And it mostly is from cage culture. And cage culture is increasingly looking like it's not sustainable. When you feed salmon in a cage, all that excess feed goes to the bottom, it pollutes the bottom. Fish waste goes to the bottom. These are very intensive systems that make bottom areas anoxic, dead zones. There's disease issues. They change the local community food web around the cages. You get predators that focus on the cages that might otherwise be doing something else, and you get escapees that begin to interact with the environment. It's the consistency. When you move that to land, then you get to control those things. You get to build sustainability into that. So that's a big advantage. And we have homegrown expertise that my colleague, Professor Zohar at IMET, which is our sister laboratory, has pioneered key technologies in RAS systems. So to review the tenets, first one, yeah, we definitely, this is a driven behavior. Sturgeon are obliged to use the Marshyhope Creek and upper Maryland spawning area. This is the sighting at Federalsburg is infeasible. The tolerance limits for sturgeon are too tight. I'll talk about that more in a minute. They're too tight in terms of accidents, in terms of dissolved oxygen, temperature, pH, and salinity. And that if aquacon is really premised on sustainability, then its site should be sustainable as well. And that's not really been considered either in aquacon's planning and rationale for siting at Federalsburg, nor in the Maryland Department of Environment tentative permit. So hopefully I've convinced you that this is defensible from a science advocacy point of view, that sturgeon have no choice and aquacon does. So now let's see how at least I move through these different steps to become an advocate. The first step is to avoid it. I don't want to step out in the public eye unless I want to. So I tried to do some behind the scenes work. I tried to do collaborative learning. I didn't know all that much about these big land-based salmon farming operations. So I reached out to colleagues at Maryland Department of Environment and Maryland DNR, those that would be involved in permitting this plan. And so let's learn about this together. And I organized and hosted a meeting with experts that had just permitted two similar plants in Maine. These plants are located or sited on the Penobscot Bay, which is a very deep, big body of water, well flushed. And then it was nice to be connected with a colleague who could link me up with those experts. I also shared that sturgeon video and some of our sturgeon data with those groups. And we came away and I thought, wow, we learned from the Maine experience that the permitting agency required a hydrology study to look at mixing levels. I said, we're at 10 to 15%. The Penobscot is de minimis, it's less than 1%. And then they required reports on things like endangered species. So they hired Norman to say, is there an impact on sturgeon and other endangered species? None of that happened in this instance. So I waited to see what happened, and unfortunately, Maryland Department of Environment went ahead with the tentative permit. In the meanwhile, I thought they might, so I started to lay the groundwork to become an advocate. And here again, kind of working behind the scenes, I reached out to NGOs, the Chesapeake Bay Foundation, which is clearly a principal NGO in our area. I reached out to policymakers, decision makers, county commissioners, the mayor, city council, Federalsburg, and then state and federal leadership to let them know that this issue was out there in case they hadn't heard, and my expertise was available to them. I also knew that I might have to communicate in the public, and you can tell I'm not great at speaking, but I do write a lot. And I thought maybe I could start writing for the public. And I always kind of wanted to. So I took this as an opportunity to learn how to write commentaries. And thinking that I might have to write an op-ed piece about this in the future. And so these commentaries were directed to kind of building the constituency for sturgeon. You know, why should you care about sturgeon? And then also talking on some of the issues that affect sturgeon, such as impervious surfaces, development of coastal canopies. The other thing I did is identify the key position, which you've already heard several times, but I also wanted to find linchpin evidence, shorthand evidence that I could provide that said would show that the sturgeon tolerances are just too tight to the site of plant microbiota. So the permit was released, and I did go ahead and write a op-ed piece. And you can see here what I'm trying to do is to create balance, because I'm not just being reactive and saying no factory. I'm saying this doesn't have to be a win-win situation. It doesn't have to be. It could be a win-win situation for sturgeon and for the RAS technology within the state. It's just we need to have that sustainability component in our siting. I went to the Federalsburg public hearing on aquaponics, spoke there. And again, I tried to make this argument that aquapon is not necessarily a bad thing. It's just we need to have the sustainable siting and try to give guidance there that, much like in Maine, we need to site these on big bodies of water that are well flushed. But if you have accidents and catastrophes, which are unfortunate, really the ultimate solution to pollution is dilution. We don't want that. But that is the ultimate risk mitigator, is that dilution factor. We have no dilution factor in the Marshyhope Creek. All right, here's the linchpin issue. And when I first brought this up to Baltimore Sun reporter, I absolutely failed. It was too complicated. You know, I started rolling the back of his head, you know, and so then I came up with this little phrase of getting my sturgeon geek on, and the reporters then started smiling, and they were somehow better prepared to say, okay, Secor's getting wound up, let's see what he's going to say. So the story here is the sturgeon magic is destroyed by salinity. So mom has these eggs inside her, she's got to release them. They're going to be slimy and slippery when she does. They're going to be released, they're going to be roiling around in the water. She's got males in her train, they're going to fertilize, and that's when the magic happens. We get this reaction after fertilization, this acrosome, cortical reaction. And what happens is there's an outer membrane surrounding the chorion, which is kind of hard membrane around the egg. This outer membrane permeates with water. Suddenly water just rushes in, and hiding in that little layer are all these wonderful proteins. And the proteins just blow up. And then all these sticky, hairy things emerge. And that's how this egg and this embryo now sticks on rocks, sticks on the ground. It absolutely has to happen. But it depends on fresh, clean water coming into the egg, blowing out those sticky elements so it can stay. And I love this picture. I know it's a little bit hard to see, getting my sturgeon geek on, but this is what we should be seeing in the Marshyhope. All these little dots are sturgeon eggs attached to rocks. That has to happen for sturgeon reproduction. Otherwise, they get buried in the sediment, they keep rolling down the estuary, and they die. This is the critical thing. And this is the critical thing that the Marshyhope Creek and the Upper Nanticoke have that other Maryland tributaries don't. Our poplar and brow are buried in the Patuxent under meters of sediment. But in the Marshyhope, it persists. And it even persists right where Aquacon is proposing the discharge. So it's perhaps a reason why we see sturgeon continue to reproduce in the Marshyhope and Upper Nanticoke and not elsewhere in Maryland. Another part of advocacy is finding people to join up with. And so I certainly got hooked up with the Chesapeake Bay Foundation, and I really want to give Alan Gerard a lot of credit. It was wonderful seeing how he operated and learning from that. One of the things he did is he herded cats. He got a group of us together, some scientists, some NGO representatives, And he managed to construct a common cause commentary. And it was hard work because I didn't agree with some things and other people agree with things. So that really was a big leadership effort on his part. The other thing is it's important not to be up front. Let other people take the lead. And what I learned watching Alan was that these people have a lot more know-how and experience than I do. And it's improper for me to advocate in areas that are outside of my wheelhouse. So here's some of the steps that I observed he moved through. And then second one turned out to be the most important one. Right away, so we need to delay for the public comment period, which I think just happened, I think technically on the last week was the due date for that. Without that, we would be facing a very different situation. I had enough political savvy to know to do that right away. And the mayor and the city council at Federalsburg have also played very important, even heroic roles in this, and saying, you know, we don't want it yet. It's not, the science isn't there, the permitting isn't there, and it has nothing to do with Sturgeon. They really investigated some of the pitfalls of this permit, and these are very specific guidelines for environment. So this happened a couple weeks ago. Aquacon dropped their permit. So this our mutual efforts seem to have worked in this instance. And you know, Sturgeon rears its head again. So we can ask, you know, this is great news, but is the mission accomplished? And I would say not completely, because we get to that third part of the shoulds. And it's, if they don't cite in Marshyhope Creek or in Federalsburg, where do they? And if we want to retain this industry in Maryland, shouldn't we be more than just reactive all the time, saying you can't do this, you can't do that? We should be proactive. Much like Aquacon moved to our sister laboratory, IMET, and their expertise to develop this, shouldn't they draw on our environmental expertise to proactively look for areas that would be most suitable for siting? And try to communicate that in this article. All right, mission accomplished. Well, the sturgeon are still there. That's great. They are no longer threatened by the salmon factory, but they still are on kind of a knife edge vulnerability. The population size of 100, that's really small. That makes it the smallest known population of Atlantic sturgeon in the species range. And we've moved on, and we're looking now at what we think is a principal threat, which is blue catfish. Anybody catch blue catfish? Eat blue catfish, run across them. Blue catfish are now the Chesapeake Bay's most dominant fish-eating fish. They're certainly more dominant than striped bass. And we're concerned that they're eating our baby sturgeon, our eggs and larvae and juveniles in the Marshyhope and the Manitou. And you can see my colleague Ian Park from Delaware. This juvenile sturgeon is the first one we captured just a month ago above Seaford in Delaware. So Manitou also goes into Delaware. And it's probably a newly 2-year-old. It's not even a 1-year-old, but it is a juvenile. We don't know if it originated. We're going to look at that with genetics, but it does suggest that the nursery function still is there in the system. Here you see recent trophy, a record-sized blue catfish in the Manitou. And you can almost imagine that sturgeon, that blue catfish eating that sturgeon. It's a little bit catfish still, but certainly smaller fish would be fair game. And this fish has been documented, feed on sturgeon, striped bass, perch, shad, anything in its way. On the right, remember I use side-scan sonar to image sturgeon. We can also image other fish. All these little purple circles, they're surrounding things that we think are blue catfish. And when we enumerate them and think about this area, you see 20 meters square there, we get about 1 meter per 30 square meters. So I guess that would be one blue catfish in this room. And if we go to acre, we get 125. And that compares, unfortunately, well to where more extensive study in the James River found a big number over 200 per acre. So they are really dominant and could be having an impact. Mission accomplished here is yes. Now that I don't have to be an advocate, the Sturgeon are their own advocate. I was really inspired when I went to that Federalsburg hearing. I really didn't know what to expect. And almost everyone there spoke against Marshyhope, the aquacon plant, but they also spoke against it because they had a lot of pride in the river and in Sturgeon. I thought Sturgeon was a secret, and these folks all stood up and said we have to conserve our Sturgeon. Federalsburg is a unique place. I really recommend it. If you're on the Eastern Shore, take a look. They have a wonderful river walk, green space area. It's just beautiful. It's obviously a town that has a lot of pride in its riverfront area. In fact, they're going to celebrate their bicentennial this summer, and there's rumors that they may use Sturgeon as the bicentennial mascot. So that's all I had. Who wouldn't love a Sturgeon? Thank you.
Thank you, Dave. So what we did last week seemed to work well. We'll do the same. We'll start with a question from the room, and then we'll go to a question from the chat. So anything from the room? Oh,
My turn.
your turn. Your turn. You go.
Sorry, I saw this couple. You're not going to ask the same question, are you?
No.
Okay.
So is it just those rocks? That's the main thing that compels them to go up the Marshyhope?
Yeah, that's a tough
So you
question.
might want to repeat the question
Yeah,
because they may
the
not.
question was, it's only the rocks. It would be almost like we misnamed striped bass rockfish. We could call Sturgeon rockfish. But that is like a needed ingredient. But there are other needed ingredients as well, related to water quality, salinity, conductivity. But yeah, the rocks are usually the kind of missing link part of this, at least in the Chesapeake, because so many of our estuaries have a high sediment influx.
What was the reference you had to the Hudson River estuary?
Well, that's their mascot. And so if you drive up and down like the what is it, the New York 8 and 7, you'll see all these little signs. Every tributary, there's a Sturgeon sign. And I always love that. I thought that was great. So that's a community that knows that they have Sturgeon in their river, just like Marshyhope Creek community has.
All right, question from the chat. Are there no other bay, river, creek networks possibly suitable for Sturgeon? Could Sturgeon fingerlings be stocked there to expand their range?
Right. So I've been careful to say this is the only tributary in Maryland where we have Sturgeon spawn. They're our only Maryland Sturgeon, because Virginia tributaries probably all of them support Sturgeon. Strong evidence in the James and the York system, and pretty good evidence in the Rappahannock. But among Maryland systems, the Marshyhope Nanticoke is the only one we know. The fingerling issue is one that I faced early on in my career. I worked with DNR, who had an artificial propagation program for Sturgeon. And we actually did an experiment in Nanticoke where we released Sturgeon and Hudson progeny into by Vienna and Rivertown, because we didn't think there were any Sturgeon there. If we knew the Sturgeon were there, we wouldn't have done that. We've done genetic tests and we see no evidence that we see those progeny in the current population.
All right, back to the room.
Yes. Yes.
What's the role of the Sturgeon ecosystem? Like, what would the effectiveness have in our bay?
Yeah, that's a great question. At their abundance level, I have to say probably very low, but historically when they're very low, and in some of these systems, I looked at historical abundance, there would have been tens of thousands of adult sturgeon returning to these rivers, so we could prove it something. At those high abundances, when you look at them, they're a little bit like a shovel. And so their heads is kind of shaking. Well, that's what they do. They kind of root around, so they mix up the bottom. They're pretty effective predators on what's in the benthos, small mussels, worms. So they would be having pretty big top-down effects. As they get bigger, they begin to feed on fish as well, things like eels they can catch. So they could have had some kind of role as a top predator in the unbenthic community.
All right, back to the chat. So blue catfish was also mentioned last week. I talked about blue catfish as a
Everybody's
potential threat
crabs.
to crabs.
Yeah.
So the question is, what support is needed to deal with this invasive fish?
Yeah. Right now, it's difficult. It's kind of a genie getting the genie back in the bottle. But I think we need, I don't know how you answered it, Tom, but I think we need better science. We know that blue catfish are terrifically abundant. We know they feed on all our nursery species that we care about, striped bass and perch and shad and blue crabs. We don't know what the predation rates are. That's a solvable problem that we can do with science to get a grip of what the extent of this issue is. For something like striped bass, it can be very important. We just had our 4th year of a really bad recruitment index from DNR. That just came out. Blue catfish are a smoking gun there. They could depress recruitment year after year like that, especially if the abundances and where they concentrate in these tidal freshwater areas, also our principal nursery areas for this guild called the endangered fish that we care about. Another one for the group.
The snakehead has gone through sort of similar philosophy. And do you think 2 of them are going to wipe out everything?
It could be like a Godzilla movie, you know,
I know.
Mothra versus Godzilla, right? So no, unfortunately, snakehead is not anywhere near the issue of blue catfish. Blue catfish, unfortunately, kind of like brackish water. And that puts them in direct threats to our anadromous fish and blue crabs. And snakehead don't do that. Snakeheads are doing what largemouth bass do. And so there's a competition issue there, but it's not as far reaching as blue catfish.
So one more from the chat. What is the status of sturgeon in the Patuxent?
We don't know. Sturgeon have a habit of visiting lots of different tributaries, but I just can't imagine there's any spawning habitat. I've been wrong about sturgeon before, but there are people, we have telemetry in the Patuxent. We occasionally hear sturgeon in the Patuxent. We have telemetry out on the pier. I've heard sturgeon there, but they just aren't showing the sizes and behaviors that we think would be indicative of spawning. Historically, they were here. The Calvert Marine Museum had a mummified sturgeon that showed me once, a little juvenile that washed up during, I guess, a hurricane of 1931. You know, Ken? Is that when we had the hurricane? It was tremendous tidal surge, and there was a sturgeon that somebody was keeping, and they brought it in. It was in the Calvert Marine Museum, so it was a juvenile, so it was kind of indicative of the price. And we have historical catch records from the turn of the century, turn of the 20th century, that can show that there were fisheries in the sturgeon.
Any other questions?
I guess if they are such a big threat and their science to come proves that, what are the options we have?
For blue catfish? Yeah. Well, we can try to alleviate the pressure. We can encourage commercial fishing, which is already happening in the Marshyhope and Maryland, that we would do an electroshocking operation that harvests blue catfish. We can. I'm on the working group in the program, and one thing they've worked towards is change legislation that allows us to, I think, what was it, processing and selling catfish domestically is difficult because the domestic seafood industry wants to protect against catfish imports. And so there's this catch-22 that they're trying to work around so we can encourage local supply with catfish to the seafood market. And we can encourage recreational fishing. You know, striped bass fishing isn't what it used to be. Every blue catfish you catch is a bonus for striped bass. So encourage your striped bass fishing friends to chase blue catfish instead.
One more question from the chat room. Does destruction of dams, such as the Patapsco,
create potential habitat for sturgeon that it has been blocked from because of dams?
Yeah, dams in the Chesapeake tend to occur above the tidal extent, above the fall line. But in other systems, I think the Kennebec, they have shown that when you remove a dam, there's been benefits to another sister species around sturgeon shortness. So yeah, dam removal can be important for the conservation of this family of sturgeon.
Anything else?
How old does sturgeon get? How big do they get?
Yeah, I helped with the Calvert Marine Museum exhibit. So if you want to see how big they get, nobody knows. You go in, there's megalodon, right? That's what everybody focuses on. But if you look up towards the ceiling, there's actually a very large Atlantic sturgeon that's 14 feet long. It was modeled after one harvested in the St. Lawrence many years ago. And we think that they can get over 60 years in age. Through that side scan sonar technique I showed, they estimated that one sturgeon was 10 feet long that they observed in Marshyhope Creek.
All right, I'm going to draw this evening to a close. I want to thank all of you for your attention. I remind you that we will be back here next week talking about diamondback terrapins. If you're on our mailing list, we will pester you with emails in the coming week. Thank you all for your attention tonight, both here in the room and online. And please join me in thanking Dave one more time.